So first up, we have our vocabulary section. We're going to match the term with its definition. On the left, you have the term. On the right, you have the definitions. Who can tell me right triangle? What is the definition of a right triangle? Okay, so Stefan says L, a triangle with a 90-degree angle. Does everybody agree with him?
Yeah.
Okay, he is correct. And then all these, I always like to cross out the ones I've used. Just makes my life easier. Oh, Lord have mercy. All right. Obtuse triangle. Who thinks they know the definition of an obtuse triangle? Obtuse triangle. It's on there. I'm looking at it.
Huh?
Obtuse triangle, folks. Look at your definitions. Nope. All right. Somebody help a friend out. Obtuse.
Wait, no, I was thinking.
J. A triangle with one obtuse angle is an obtuse triangle. Yeah, it did. Acute triangle. A triangle with all acute angles. Equilateral triangle. That's why we're reviewing. Close. It's not E, because lateral is not. Yes, it is D. A triangle with three congruent sides. So lateral means side. So it's a triangle with three congruent sides. Now, it just so happens that it would also have that for triangles, they are equilateral and equiangular. So that wouldn't necessarily be super wrong. Isosceles triangle. Yes, very good. B, a triangle with two congruent sides. That is our isosceles triangle. Scalene triangle. H, a triangle with zero congruent sides. That is a scalene triangle. Perimeter. Not A. Not M. C, the length around a shape. So when we think of perimeter as if we were to walk around the outside of a shape, how far would we have to go? Polygon. You know what? Actually, this one somehow did not make it in here. So we're gonna do this. A polygon is a shape with many sides. That one I apologize. That one did not make it in. So a shape with many sides. Remember, poly means shape, gon means sides, or sorry, poly means many, gon is our shape or side, so a shape with many sides. Similar polygon. Similar polygons. This is going way back to like January. Yes, I missed the definition on there. Nope, not K. Similar polygons. Not M. F. Shapes of different sizes with the same angles and proportions. If you think way back to like late January, early February, when we were using proportions to find lengths of triangles that were similar, but they were just kind of like one was a blown up version of the other one. Hypotenuse. I, the longest side of a triangle opposite the right angle. Trigonometric ratio.
Wait, no, I think it's F. Wait, we already done that. I think it's E.
It is A, the ratio of two sides of a right triangle. So remember that sine, cosine, tangent.
You said
Regular polygon.
K. I mean, I said N.
Oh, I somehow, I see what happened. I put obtuse triangle on here twice and missed that one. So regular polygon is
N.
M, a shape with all sides and angles congruent.
Next one. E.
It is not E.
It's K.
It is K. Remember, lateral means side. So a shape with all sides congruent. So then what is, so equiangular polygon?
E.
E, a shape with all angles congruent. There, we're already through the first part.
Yeah, that was easy part.
All right. Flipping the page in 5, 4, 3, 2, 1. All right, part 2, we are identifying the triangle by its angle measures. So if it's acute, obtuse, right, or equiangular, and sides, equilateral, isosceles, scalene. And we literally just reviewed what all of those mean. So let's look at number 1. What kind of triangle do we have here? What kind of angle measures? What? So that would be sides, right? By sides, you're right. It is equilateral. What about by angles? You literally have a list of 4 choices up in the instructions. So here's hold on, don't laugh. We could say acute because these are there's one that's okay, hold on. There is one that is a better fit. You are right. This is an acute triangle, but there's equiangular is the better fit because they're all the same. But you could also say acute.
So I was 80% right.
Yeah, I'd say that.
That's what I'm talking about. That's still that.
I'm going to be honest. If you are on the final and we have a triangle like this, AL. It's also right up here. If you are on the final and you have a triangle that looks like this and you identify it as an acute equilateral triangle, I would accept that. Equiangular is the better answer, but acute is technically correct. All right, let's look at our next one. By angle, what kind of triangle is this? Acute, right, obtuse, or equiangular? Look at her. Right. When we see this, we automatically know that is a right triangle. What about by sides? How many sides are congruent in this? 2. What kind of triangle has 2 congruent sides? Isosceles. You can. Isosceles is a Dickens of a word. If you need to write iso, as long as I know what you mean, don't do that. Okay, let's look at the next one. By angles, what kind of triangle is this? Acute, obtuse, right, or equiangular? Obtuse. Our biggest angle is greater than 90 degrees. This is obtuse. How many congruent sides are in this bad boy? No. Look at your tick marks. You have 1, 2, 3. So we have no congruent sides. God, that bell is so long. We have no congruent sides. So what kind of triangle is it? Scalene. All right, I'm gonna give you guys a second while I shut the door because the hallways are about to get loud. And guys, we literally have one more page, and it's got, I think, 2 problems on it.
Still like,
Yeah, I told you guys it wasn't gonna be super long, but y'all don't believe me. All right. Last page. Dear God, please tell me you guys remember this one. The interior angles of a triangle add up to 180. Excellent. The interior, and notice I underlined interior. The interior angles of a triangle add up to 180. We've been working with that number all semester. So we have 2 triangles with missing angles. How are we going to find that missing angle? So we know, right? So we could set up like this. 180 equals 37 plus 63 plus u. We know that 180 is all of those added together. So when in doubt, write out your formula and just plug that letter in for whatever your missing number is. We know that all of these added together equal 180. So we can, yes, you get to use, I let you guys use all this stuff on your test. The final is no exception, because here's the deal. In the real world, when you need to do something, you look it up. I mean, when I was in school, the internet was like a baby back then, and you didn't have it on your phone, so we had to do it. But like, honestly, like nowadays, you're going to look stuff up, but you have to know how to apply it. So yes, you get to use your notes. So what's our next step? We have our equation set up. How are we going to solve this? I mean, you are going to need the calculator. You're right. How are we going to solve this? Okay, so first thing we want to do is combine like terms. So the first thing we need to do is we need to add our 37 and our 63 together. Somebody stick that in your calculator. Tell me what you get. 37 plus 63. Yep, it's 100. So we end up with 100 plus u. Okay, this is more manageable. What's my next step? Not divide, subtract, right? Because I want to think of what's the opposite. In this case, I have 100 plus u. 100's a positive number. The opposite of that is subtraction. Whenever we solve an equation and we need to move something to the other side, we always do the opposite. So what's 180 minus 100? Right. I thought I heard somebody say it. 80. So the measure of angle u is 80 degrees. I'm going to give you all a moment to get caught up. Is everybody good on number 5? Okay. Final one. How are we going to set up the equation to solve this? Who wants to give it a stab? Back over here until we're done. Okay, 180. We have one more measurement in there. What's our other measurement that we've been given? 90. So 46 plus 90. I'm going to use B because it's the measure of angle B. You can use X. It doesn't matter. 90 is right here. So remember when we have this, that's our 90-degree angle. That's why I really find it helpful when I see that to just write the 90 in. Because I have found myself doing that. Like when we were doing measures or finding missing interior angles on some of these bigger polygons, forgetting to add the 90-degree angle in there because it wasn't written out. So I would just stick that in there to remind yourself that that is a 90-degree angle. All right, so what's the first thing we need to do on this equation? Yeah, add 46 and 90 together, which gives us what? What could you use to find it out? Your calculator. Yep, so we have 136. And then I just like to bring everything down because I find it helpful. Okay, what's the final step in this equation? Not divide. We only divide, so divide is a lot of times our final step, but that's when the variable and the number are touching with nothing in between. In this case, we have that addition symbol, so we're going to subtract this because we do the opposite. All right, somebody stick that in your calculator. 180 minus 136. Wah, wah. You have to have a little fun. Makes class go by faster. Are you taking a nap? Somebody stick that in your calculator. Yep. So the measure of angle B is 44 degrees. Are there any questions about how we got here? So if I stick a problem like this on Wednesday's bell ringer, you guys can do it. Okay, what is your question? Okay. All right, get your Chromebooks out.